Good morning. Welcome to API Days documentation and complexity track. I say complexity track because that's a little bit new. It's also really exciting because it's the first time that we'll have presentations on the topic of complexity at the documentation and developer portal track. But it's something that I've been really looking forward to, and I've been trying to make happen for quite a while. And today it's finally happening. Before I get started, I want to say thank you to a couple of people. First of all, thank you to the organizers of API Days. There's an enormous amount of work that goes into bringing everybody on together and making everything work and coordinating that is happening. So thank you very much for all this work that you've been putting into this event, for keeping it happening, even through the pandemic. I'd like to say thank you to my colleagues, because they were also in the background helping, bringing people onto this track, making sure that we have a good lineup, and I will have some speakers to talk about the topic of complexity. And yeah, but then without further ado, let's get this party started. So, as you've seen in the program, or maybe not, we've got this first talk, APIs and complexity, in initial lineup. And it's a bit weird because I'm also the MC and the first speaker. But I wanted to give a short introduction to complexity, because most people, when they hear that word, they're thinking very different things than what the full potential is of complexity and the concept of it. So this talk will be a short introduction to that, and then after that there'll come a talk with Mark Bergauer, who's going to talk about a further expansion on the concept. But before I get started, a very short. I'm Kristof Van Tomme. I'm the CEO of Pronovix. You'll hear in this talk about why you should care about complexity and potential value of complexity and how you can use it to create value. My company is Pronovix. We're a specialist in developer portals. If you want to talk about developer portals, or you want to just get some advice, just get in touch. I won't talk more about that for now. I'll be focusing on the core of this talk. Because I don't know if you've ever, well, I'm sure you have, but how much have you thought about what we're really doing when we are creating API programs? What is it actually that is happening here? Most of the time when I talk to people, it's kind of like a given. Like we're doing this rollout, we're going to do APIs, it's it's just yeah, we're doing this technology thing. We need a developer portal. We need this. We need that. Or some a little bit more mature organizations will have very clear ideas about, okay, we're going to build an ecosystem. We want a marketplace where we're going to have this kind of participants, that we're going to have this kind of APIs for, and this is how it's going to change our organization. Maybe they'll have ideas about improving internal efficiencies and improving reuse of certain assets, so that different departments are not building the same thing all over and over and over again, but that there's like more reuse. But very rarely I've heard organizations think or talk about complexity, about how this is going to change them as an organization. How will it transform the organization? There are some reverberations in the community around things like value streams and like team topology is a really interesting concept. But it's not strictly clearly explained, like how does this all fit together and what's the big story here? And this is, I think, a really essential piece, because I think that if you don't fully understand, if we don't have a shared understanding of what we're trying to achieve, we're not necessarily going to get what we could or what we should be achieving. Because how does an API program really impact an organization? How does it change an organization? I believe that it has a lot to do with this picture. This is like, you know these beautiful pictures. Coral reefs are amazing ecosystems. I believe this is kind of what we're doing when we're doing APIs. We're creating boundary systems that enable complex adaptivity. That's a lot of complex words, but this is what I'll try to explain a little bit, and kind of laying this link between biology and biological complexity and the social technical systems that we live and work in and build software for. Because complexity is not just about bad code. I assume that you're already here if you're attending this talk, but in some cases, I wanted to make a clear statement about it so that it's clear that I'm not talking about complexity as the thing that you're trying to eliminate. Actually, in fact, I think that there's a form of complexity that you might want to deliberately try to achieve, and that you might want to deliberately try to cultivate and improve because it's actually useful. So, but what is that other way of defining complexity? And where can you learn more about it? So I think in the world of complexity science, because there's actually a world like that, there's a whole academic circle of people that are doing research about adaptive systems and how they behave, and what are the parallels between different systems and different layers of emergence. And there's a very interesting picture evolving there that talks about the parallels between living systems. And these same parallels can be used both for biological systems and for social technical systems that we interact with. I've been excited about this for, well, probably decades. So I got excited about chaos theory and that kind of stuff. But it's the problem with this is that it's very much a complexity kind of thing. It's this hand waving, not very clear concept, or it's really difficult to explain it often, or at least for me, it took a while to understand it. And I got a much better understanding after listening to this audiobook, Understanding Complexity by Scotty Page, who's a professor who's doing an academic course on complexity, where he explains kind of a certain range of the concept in this field. And he said something really interesting in this book, that there's these four parameters, interconnectedness, interdependence, adaptiveness, and diversity, that are important to start or to create complex behavior of a system. So that when you have a system of connected agents that are interconnected, but not fully interconnected, so there's still some edges that are missing in the network, that are interdependent, but are not fully dependent on each other. So there's still some semi-autonomous behavior, that are adaptive, but that are not just unthinkingly following each other or unthinkingly reacting, but that there's like some, there's adaptation going on, but it's not instantaneous and complete. And when you have diversity, but you don't have everybody's different, but there's like this interesting mix of groups and then like significant diversity in the system. When you have all of these four together, you get this interesting behavior that happens in the system that creates this unpredictable adaptiveness that is so characteristic of living systems and of ecosystems all around us. Another Another way of expressing this is was defined by Stacey in the Stacey Matrix. In the end, he originally this was something that was being used for management consulting. In the end, he moved a little bit away from this because people were using the model in just unthinking way, and whenever you're using models in an unthinking way without contextualizing them, you always end up in bad places. But still, it's an interesting model to explain what we're talking about when we're talking about this kind of complexity. As you can see, it's a little bit like a phase diagram that you might know from physics, where there's four phases. There's the simple domain, there's the complicated domain, there's a complex domain, and the chaotic domain. And when you see the complex domain is this broad area where interesting stuff happens. It's not the chaotic space where it becomes unpredictable, but it's like, there's lots of interesting, it's exciting and interesting. New and novel things are popping up and are becoming, and the interplay between the different agents are creating new interesting solutions in this space. Not all the agents are agreeing, and there's things are not fully certain, but there's an interplay between these things that creates this behavior. Also in the book, Professor Page talks about this visualization of the four types of systems. So there's the simple systems, where it's kind of like a single mountain, like a lonely mountaintop. You just keep going up and you get to the top, and it's easy to maximize or to optimize because you just keep going up. There's the complicated systems, where it helps if you have a guide that can lead you to the right mountain to start climbing, because if you start climbing the wrong mountain, you might get onto a suboptimal optimization. There's chaotic systems where you better try to get out of it because nothing is predictable. It's just a mess. It's not a good place to be. And then there's complex systems that provide this dancing value landscape where the interaction or the actions of each of the players that are participating has an influence on the rest of the players, and they need to adapt, and you get this infinite play of interaction that's going on. The thing that we typically know from social context and from economical context. So, and when we look in the world, we see that pretty much every natural environment is complex. There's at least when there's life present there. I guess you probably in deep space there might be some pockets of complicatedness, although even there, I can imagine that complexity still arises. Maybe in like a crystal where everything is ordered, but if you look around you in nature, you'll see complexity arising all over the place, and that's crucial. That has a huge impact on the systems that are trying to live in those environments. Because in the 60s, Ross Ashby developed his law of recursive variety. This was back in the cybernetics age, when we still thought that we could control our environments. But he developed this concept that if you are a system in a complex, in an environment that's really changing a lot, or where there's a lot of different states of the environment, that you also have to have a similar number of states on the inside. So you can't adapt to a system, or you can't adapt to a really complex environment if you don't have a lot of variety on the inside. He didn't say that you can't adapt to a complex environment if you are not complex yourself, but that's kind of the implied thing here. And that's important because when you're trying to adapt to complex environments, it means that you also have to have that variety on the inside. So basically, by definition, living systems are complex adaptive systems. And the way that living systems do this, and this is the connection to APIs, is that they're using signal boundary systems to create pockets of resources, pockets of energy and information, where there's a far from equilibrium state, where different interesting things are happening that are not possible in other places. And then they're using these semi-permeable membrane systems, these boundary systems, to interact with the rest of the world, to coordinate and to do what life does, and this interplay that is happening in living systems. What the practical outcome of that is that this is, for example, in your gut, you have this adaptive membrane layer that provides an interface between the microbiome and your immune system and the rest of your body, that together create this fascinating living thing that can eat a bunch of different things and still be fine and function in a wide variety of environments on a wide variety of diets. What does it all have to do with APIs? The thing is that when you put a living being into a system, almost by definition, that system becomes complex itself also. So if you put a human, and almost all of our machines, all of the things, the devices that we work with, it's humans that are interacting with them, that are doing things with those machines. It's also humans that are maintaining them. It's humans that are developing them. So almost by definition, everything around us has this complex property, this complexity as a property for around us. And as humans, I don't know if human systems are more complex. Probably it might be a salience factor, but you probably will agree that there's this unpredictableness to human systems, or wherever humans are present. And you probably will have also seen that there's these adaptive interfaces that we are developing in economical settings to help us deal with that. And here come finally to APIs. What we're doing is with APIs is we are creating interfaces between different subsystems to help to address this complexity, I believe. And it's kind of like a move from human-mediated interconnection to machine-mediated interconnection. And it's really important and this is why I believe complexity is so important, is because as long as there's a human in the middle, they could kind of play this interconnection role and this adaptation to complexity thing. But as we are moving towards machines as the connection between complex subsystems, between the customers and teams, between teams and the rest of the company, we need to understand complexity, because if we don't, we risk creating systems that are not really nice to live in. So that's why I believe it's important to have a broader view of what we are doing when we're creating API programs, to realize that what we're really doing is that we're creating evolving complex adaptive systems, and that we are pushing this further, and that we don't unwittingly optimize for efficiency, but that we also think about adaptivity, and that we use APIs as the way to balance both of these. Because I believe that APIs can help to nurture useful complexity, this deliberate complexity, to help to solve this trade-off between efficiency and adaptability. There's some more story here. There's a whole story about dynamic decoupling of a programmable information layer. I'll talk about that tomorrow on the interface manifesto session. But for some, like a last takeaway for your management, why you should care about complexity. Basically, complexity can become a source of value. If you look at places that are complex, things like traffic, you'll see that there are parties evolving that help to mediate that complexity and to guide other people through that complexity. So when you can find a way to harness deliberate complexity, it can become a source of value that's really hard to replicate. And that can be, a good way of doing a business and running a successful, long-lasting business. So I hope next time when you're dealing with technical debt, you think about this talk and you won't just look at this and say like, oh, what's all this crap? But you'll realize and appreciate the fossilized complexity that you're interacting with. That's it. If you're interested in this topic and you would like to learn more, go and check out this link because we'll be doing an event series about this specifically. And yeah, and I hope to see you there and hope to interact with you on complexity topics in the future. And that's it for my talk. I want to create space, different screens, for some questions now. Okay, are there any questions? Was this useful? Was it interesting? Do you understand? Did you have this understanding from before? I think maybe we can already bring in Mark, Matteo, so that we can just discuss a little bit before his presentation. Hi, Mark.
Hi, Kristof.
Thanks for joining. Like for the audience, Mark Bergauer is. Let me peek at my notes because I know you as one of the founders of Contextualize, but you wanted us to mention that you're working as an agile coach for the Registers of Scotland, and that you're also a biologist by profession and by education, right? And
actually, just by education. I never worked as a biologist.
Okay.
I studied biology. I'm Swiss. I didn't want to work for pharma, which almost all the biology jobs in Switzerland are about. So while I was hoping to find some other occupation in biology, I started doing some computer work to earn some money, and I got stuck.
Okay, that's kind of like that resonates with me. That's a similar story for me. It was also, well, I was not necessarily trying to get away from pharma, but it was similar. Also, getting stuck in software, and then sticking around for the community, I guess. You've had a startup and you've built applications. So it's interesting that you ended up becoming an agile coach, and then like figuring out your path also into complexity. But I think that's going to be the topic for your talk in a moment. How did I
talk about myself? But
sorry,
I'm not going to talk much about myself.
Yeah, but well, so I need to do some of that. So go check out what Mark is doing with his colleagues. There's some really interesting stuff. The social practice theory and Contextualize. It's really exciting and interesting complement to, I think, what we're doing with APIs. Was there any, like, how did I do in my talk? Did it resonate? Well, we coordinated one before we.
Yeah, we talked a little bit about it.
We talked a little bit.
So yes, I liked your talk.
Okay, good.
But, proof is in the pudding, so
yes,
comes down to the audience.
Yeah, let's see what people say about it. I think we're almost at the time mark. So you're going to be talking about APIs as a new skin of your organization. which is a further, like it continues that story about membranes, and so I'm really excited to see how it in the end turned out, and I'd like to give the floor to you, Mark.
Okay, thank you, Kristof.